Welcome to A-Level Physics with Mr. Marshall. Thank you for watching this presentation. I'm hopeful by the end of it you will have answers to your questions about what the course is about, what we study, how it's assessed, what you'll need, and any sort of preparation you need to do for the starting of the course in September. Up until now, we've taught you the basics of physics through GCSE. Most of you would have been completing the triple science or separate sciences course. At A-level, we start to now extend that knowledge and we go to a depth far greater. So, for example, if we look at the particles and radiation section, we taught you that there are 3 particles in an atom. Well, we start to now look at actually what are those particles made up of and how they interact with each other. The beauty of A-level physics is that it goes from the smallest of matter right up to the largest of matter. So how did we get here? What made us? What makes up everybody? What makes up everything? How does everything interact with each other? Physics tries to answer those questions and doesn't know all the answers, but we strive to find those answers. So in 2015, the course changed. So that's the specification we run on now. It means it's a linear course, and that means you have 3 exams at the end of the second year. On top of that, if you meet all the criteria, you are awarded a practical certificate of competence. Quite a lot of universities now require that certificate. So in year 12, we studied the following 14 topics that you can see on the screen. I don't start necessarily with particles and radiations. I tend to start with vectors and scalars, move through the mechanics section of physics into Newton's laws, and then into materials, electricity, and then finish off on the particles, quantum phenomena, waves and optics. This is usually because I find students transition to vectors and scalars easier than they do through to particles and radiation. In year 2, we then have 4 compulsory topics, which are periodic motion, thermal physics, fields and their consequences, and nuclear physics. On top of that, we then have one of the optional units, which is astrophysics, medical physics, engineering physics, turning points in physics, and electronics. It's up to us as a class which option we choose. I tend to do no more than 2 options because I can manage that within the teaching. But it's a conversation we have probably about a quarter of the way through year 13. So in year 13, you will have 3 exams. Paper 1 concentrates purely on material from year 1, plus circular motion from year 2 material, which you pick up at the end of year 12 or beginning of year 13. The exam's 2 hours, it's worth 85 marks or 34% of your final A-level qualification, and that's made up from 60 marks of short and long answers, which can include calculations, deriving equations, written answers, and then 25 multiple choice answers, questions. Paper 2 is made up from your final compulsory components, which are thermal physics, fields and nuclear physics, plus it also can ask questions from your year 1 material. Again, it's 2 hours long, 85 marks, 34% of your final A level, and 60 marks short and long answers with another 25 multiple choice questions. Paper 3 is then broken into two sections. Section A is concentrating on the practical skills and data analysis work that we do throughout the whole course. This focuses on required practical work and also the skills you obtain through your practical elements of the course. Section B then concentrates on one of those options that we choose, which I mentioned a couple of slides ago. So if we chose astrophysics, that section B would be the astrophysics paper, and it would only have questions from that topic. Again, 2 hours, 80 marks. It's not a case you have to do one paper for 1 hour and one paper for the other hour. You get both sections on your table at the beginning of the exam, and you have 2 hours to complete both those sections. This is made up from 45 marks of short and long answers again, and 35 marks on the Throughout both year 12 and 13, you will do 12 required practicals in the same way you did for your GCSEs. That I have to complete those 12 required practicals because they make up some of the practical element of paper 3, which I've spoken about on the previous slide. On top of that, we do a large number of practical experiences, so a number of different experiments, and when I feel it appropriate, I then judge you and how you perform and how you manage those experiments through 5 different competencies, which you can see in the middle of the screen. I have to evidence that you've met those 5 competencies a number of times, and throughout that monitoring we may receive a visit from AQA where they'd want to check how that monitoring is taking place and observe you completing a practical. That's more for the administration aspect of it, to ensure that when I recommend students for the practical endorsement, it's based upon evidence that meets the criteria. If I feel that you've met those competencies, you then end up with that certificate of practical skills, which is, as I've said, something that universities are quite keen on. Like all courses, you will need your own stationery. So we provide you with textbooks. I've got 2 different textbooks I use, which is the CGP, that falls in line with the revision guide and the workbook quite nicely, and also an AQA physics textbook, which we have in school for you. On top of that, you need to provide yourself with ring binders, folder dividers, a scientific calculator, obviously normal stationery, pens, pencils, ruler, protractor set square, and then you've got the option to purchase revision guide and practical skills workbooks. So what happens now? Well, I suggest if you haven't already joined the Microsoft Teams pages for the year 11 to 12 physics group, let me know and I will add you. There are on those pages 2 transition book packs. I suggest you complete one. The idea of that transition pack is to kind of give you an experience of the skills required for A-level physics. And then also you might want to complete a research project into how physics works. So the example I've put on the screen here is the Millennium Bridge that was built around the turn of the millennium, and it was closed quite quickly after it had been built because it was wobbling too much. So they required physics to identify what the issues were and then come up with a solution to fix it. We also get the opportunity to look into visiting CERN, which is in Geneva. That depends upon numbers of students that are willing to participate on that trip. But even if we do or don't go, it might be something that you could find interesting to research into. So my final tips: you need to be organised and committed to spending time on A-level physics. It's one of the hardest A-levels to complete. You have to keep on top of the work. You have to make sure you manage your time. And for every hour in lesson, you need to be spending at least an hour outside of lesson doing additional work, going back over worked examples, going over questions, researching and finding information about topics that we're studying to extend your reading. I hope you found today's presentation useful. If you've got any questions, feel free to email me at school.